Bing. Recording. Got audio. Yep. Right. We've been looking in this chapter at being able to describe data sets. And the idea being to describe large data sets, distributions, in ways that are meaningful to give you a mental image of how the data in that set is distributed. And we've come up with measures of central tendency. What else? Measures of variation. And measures of position. Measures of central tendency. What were some of those? Mean, median, mode, range. Well, no, range is measure of variation. Yeah, we also had variance, standard deviation, measures of position. Well, we had our z-score, percentiles, and quartiles, which are quite as useless as deciles. Today, we're going to look at something called exploratory data analysis. This is what you do to determine whether or not it's worthwhile to bother with doing a formal traditional analysis of the data. In a traditional analysis, EDA, which stands for exploratory data analysis. Okay, now in traditional analysis, how do you tabulate your data? Yeah, you do a frequency plot. On EDA analysis, you would do stem and leaf. Okay. You remember the stem and leaf plot? Okay. What would you use for your measure of central tendency? In a traditional, you would use the mean. EDA will use the median. You remember the median. That's the middle of the data range, the data values. not not necessarily the middle value, but the middle of the data. What do we use for the measure of position? I'm sorry, not position. So measure of variation. The traditional analysis, you would use the variance and the standard deviation. In EDA, you're going to use the interquartile range. Remember what that is? Don't worry about it if you don't. We're going to hit it in just a minute. Finally, for graphical representation. Traditional. Use histogram, ogive, the frequency, polygon. In EDA, we're going to use a different one. We're going to do what's called a box plot, which is a whole lot. And you're going to see that the whole purpose behind this is just to give you an idea of how the data compares to other data. It's like we're dealing with very broad strokes, ballpark pictures here. So, the first thing you need to know about if you're going to do the exploratory data analysis is the 5-number data summary. Okay? That's actually, that's just another name they came up with for the 5 quartile boundaries. You've got essentially Q0. Below this, there's no data in this data set. Q1, a fourth of the data is between Q0 and Q1. Q2, where a fourth of the data are between Q1 and Q2. Half of the data is between Q0 and Q2. Q2 is also the median. Q0 is the lowest data value. Q3 is halfway between Q2, the median, and the maximum data value, and Q4 is the maximum data value. It's the one that below that there's all of the data, 100% of the data. So, they use an example here, 337. The number of meteorites found in 10 of the United States are given as 89, 47, 164, 296, 30, 215, 138, 78, 48, and 39. One, two, three, four, five, six, seven, eight, nine, 10. That's the number of that's from 10 states in no particular order. We found 89 meteorites in this state, 47 in this state, etc. So the first thing we need to do, because we're going to be doing this in quartiles. We're going to look for the median, we're going to do quartiles. So the first thing we do is we rewrite these in ascending order. Well, the lowest one is 30. Next would be 39. Next after 39 would be what? 47. And then 48. Yeah, 48. So we got 47, there's 48. Next one is 78. 89. 138. 64. 215. 296. Okay, we got them all. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, just to make sure. Okay, well, Q0. Or the lowest data value is 30. We're looking for 5 numbers now. We are also going to want Q1, median, Q3, and Q4 are max data value. Well, we can find max data value right now. It's 296. What's our median? There's 10 of them, so we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Median is going to be between 78 and 89. And we get that by adding 78 plus 89 and dividing by 2 equals 83.5. So our median is 83.5. Now I want to make a point here just to make sure that you pick up on this. What if we took the midpoint between 30 and 296? What if we did 30 plus 296 divided by 2? What does that equal? 163. That's close to double the median. So the point is, this is not the median. What is this one called? Mid-range. Remember, the range is 296 minus 30, 266. The mid-range is the halfway point between those two values. Or would that be 266 divided by 2? That's a good question. We'll have to look that one back up. Point is, this is not the mid-range. This is not the midpoint, the average of the data values. It's not the midpoint between the two data values. It's the average between these two middle data. If this had been an odd number of datum, then the middle datum would be the midpoint, the median. So now, in point of fact, because it was an even number. We divided it, and now we've got two odd number data sets. Where is Q1? 47, and Q3 is 164. This is our 5-number data summary. And we will use that to construct a box plot of this data. Now, here's how we do that. We're going from 30 to 296. So the first thing we do is we establish our axis. And we could make the endpoint, this endpoint 30, and this endpoint 296. But the axis is going to look better, and the graph is going to look better if we use round numbers. So we could make this one 25 or 20. Let's just make it 0. And this one has to be greater than or equal to 296, so 300 works. And we can now just divide this into 100, 200, 300. There's 150, 250, 50, 25, 75, 125, 175, 225, 275. That's a good axis. Where is our low point? 30. So that's 50, that's 25, it's going to be about right here. That's our lowest data in the set. Our highest data in the set is 296. That's going to be about right here. Now, where is Q1? 47, so that's 50. 47 is going to be about right here. And Q3 is at 164. Well, there's 150, 175, 164 is about right here. Here's the first two lines in the box plot. A horizontal line from your minimum data point to Q1, and a horizontal line from Q3 to your maximum data point. Now, you just draw a couple of vertical lines at Q1 and Q3 and connect them. Then, add a middle vertical line at the median, which in this case is 83.5. So 80 about right here. There is a box plot of this data set. Yep. The way to it, but here's how you interpret it. It's kind of negatively skewed. Okay, if this were a nice normal distribution, your box plot would look like that. A negatively skewed one looks like that. A positively skewed one like so. Okay, so you see how the picture gives you a visual, not a, you're not going to get any detailed analysis from it, but it's going to give you a nice visual of how this data is distributed in that range. It's very much, it's broad stroke generalizations. It's just, we're not trying to analyze the data per se, we're just analyzing it enough to see if there's something to be looked at. So, let's apply this and work through this, applying the concepts 3-4 on page 179. The noisy workplace. Okay? We've got 1, 2, 3, 4, 5, 6 data sets with 15 data in each set. They are sound level measurements at 6 different areas in a workplace. Because OSHA got some complaints from some whiny little snot-nosed union wannabe, and he's calling in the regulators to stick it to the man, trying to tell him what to do. Yeah, whatever. But the point is, they did this analysis. Now it says that the safe hearing level is about 120 decibels, so decibels, not decimals. That's a different thing. Decibels. And the question is, do these data suggest that there should be some further investigation into whether or not the factory is in compliance? So, let's start with area 1. What's the lowest value there? 12 looks like, right? Okay. So we go 12. And the next one, 24. Okay, what's the next one? 30. Okay. And next would be 35, 32. Okay. And 35. Okay, what comes next? There's a 44 and a 45. You see how this would be convenient to make a box, not a box, but a stem and leaf plot? Because now you just, you find all the 2s and all the 3s and all the 4s. Yeah. But let's plug through this way, doing it the hard way this time. Try a stem and leaf plot on the next one. See if it makes how much a difference it makes. Okay, after 45, we did 44, there's 45. Yeah, okay. And then 57. After 68, yep, 92. I see 100. Is there anything between 92 and 100? Okay, well, is that 15 data? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's 15 data. That's all of them in order. Okay, so our 5-number summary. Lowest is 12. The highest is 100. The median is 56. That leaves 1, 2, 3, 4, 5, 6, 7 below 56. Our Q1 would be right here between 32 and 35. And Q3 would be 61 plus 65 over 2. Okay. All right. There's our five number summary. Now, this is for area 1. Now let's do area 2, but this time let's do it as a stem and leaf plot. I see we've got some 60s and a 90 and an 80. Got a 5 and a 20 and a 10. And we've got a 7. Go 8 and 9. Do we have any 10s? Nope. So, all right. Well, in the 1, we got the 16. That's there. Do we have any other 10s? Don't see any. Or, you know what? Why not just make it easier? Let's just start at the top and go down. And we can put the leaves in order individually rather than trying to do it all at once. So, 99. We've got a 64 I missed. 99 and 87. 59. 23. I've already done the 16. We've got a 94. A 78. 57. We've already done 178. Is that a different one? It sure is. Okay. And that's a whole nother 59. And then 2 55s. All right. Well, we can start at the top. We've got 16, 23, 32. We've got nothing in 40s. We've got 52, 55, 55, 57, and 59, and another 59, and a 64, and 2 78s, an 87, I'm running out of room, a 99, 94 to 99. Let me rewrite this so I don't scrunch them up like that. 16, 23, 32, 52, 55, 55, 57, 59, 59, 64, 78, 78, 87, 94, and 99. Yeah, better. Count and make sure we got 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Bing. So 1, 2, 3, 4, 5, 6, 7, 8. There's our median. 1, 2, 3, 4. Q1 is here. 1, 2, 3, 4. Q3 is here. So we need 52 plus 55 divided by 2. And 78 plus 78 divided by 2 is 78. And 16 and 99. So, A2, we've got 16. What's 52 plus 55 over 2? 53.5, 59, 78, and 99. That's area 2. So what do you think? That one was easier to do. Went a little quicker, didn't it? Okay. Area 3. What's the low? Do we have any 20s, 30s, 40s? No. Yeah, we got 50s, and we got up to 100. So 50, 60, 70, 80, 90, and 100s. All right. Well, first one, we've got a 100. And then we've got a 59. And then a 78. And then a 97. And an 84. 64. Keep calling them. 57. Okay. Let's start at 53 as our lowest. And then a 57. And then two 59s. And then a 62. And two 64s. And a 66. And then a 78. And then an 84. 88. And an 89. And a 94. And a 97. And a 100. Now, is that 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. There's Q0 and Q4, 5 or 4, or lowest data and highest. Our median is right there. 1, 2, 3, 4. That will be 88 plus 89 divided by 2, which should be 88.5. And this one should be 59 plus 62 divided by 2. A3 is 66, 100, 88.5, and I'm not trying that one in my head. That's okay. 60.5. Boom. That one went quick. I'm sorry, say again? Trying to just suss them out one by one, yeah. Yep, there's a reason they decided to do it that way. And it wasn't just so we could throw statistics students curveballs on exams. All right, now A4. We've got a 10, got a couple of 10s. And what's the highest one we've got here? I see a 60. No, I'm looking at over the highest datum is going to be the 61. I don't see anything higher than the 60s or less than the 10s. So 10, 20, 30, 40, 50, and 60. Now, you call the numbers to me. We're working area 4. $52. We got no 40s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. In order, we go 10, 14, 15, 20, 21, 22, 24, 25, 30, 32, 33, 34, 52, 56, and 61. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. 10, 61. 25 is our median. 20.5 is our Q1. 33.5 is our Q2. Q3. So our 5-number summary for area 4 is 10, 20.5, 25, 33.5, and 61. Boom. This is going quick. We just got 2 more to do. All right. In area 5, I see 110s, 130s, 140s. There's a 160. We got them all the way up to 160s. What's the lowest? Anything less than 59? Nope. All right, so we're going to go from 50s all the way up to what, 160? Yep. 60, 70, 80, 90, 100s, 110, 120, 130, 140, 150, and 160. Now, you call them off to me. 69, 63, 81, 110, 65, 112, 132, 45, 163, 120, 105, 75. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay. Now, we start with 59. And we go 63, 66, and 68. 75, 81 and 84, 99, 105, 110, 112, 120, 132, 163. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. There's 59, 163. Median. 68 plus 75 divided by 2. 112 plus 120 divided by 2. Okay. All right. That's not right. You didn't clear your registers or something. That'd be 232 divided by 2. 116. That looks better. So, A5, and we've got 59, 71.5, 99, 116, and what? 163. Okay. That leaves one more to do. We can start drawing pictures, but I'm going to change my marker because this one's dying on me. Okay. Our last one, A6. Now I see a 40s. Oh, and a 20. And they go up to 120s. All right. 20, 30, 40, 50, 60, 70, 80, 90s, 100s, 110s, 120s. All right, you call them out. Two, three, four, five, six, seven, eight, nine, 10. That's 15 of them. All right. 21, 34. 45, 49. 56. 66. 67 twice. 80 three times. 93 and 99. 100 and 125. Is that 15? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It is. So we got 21, 125, 67, 49, plus 56 over 2, and 80 plus 93 over 2. $86.5. So A6 is 21, 52.5, all right. Now, since we want to compare these, it's best if we put them all on one chart. So, we're going to have a highest number on our chart is going to be 163, and the lowest is going to be 10. So, we're going to go, let's go 0 to what? 175? Is that right? Let's see. 25, 50, 75, 100, 125, 150. Boom. Look at that. Like I knew what I was doing. All right. A1. We go from 12 to 16. I'm sorry, 12 to 33.5. And then we go from 63 to 100. And our median is 56. That's A1. Or we could write just like that. All right, what is A2? Well, A2 starts at 16. You know what, I want to no need for them to be that tall. All right. So we'll go from 16 to 53.5. And at 59. And 78. And then 99. There's A2. That 59 is, well, that 53 can't be right because that's 56. That means, try to get these right. That's getting pretty close to as best as I can eyeball it. All right. A3, we start at 53. We go to 60.5. It's going to be about right here. This will be 60.5. Our median is going to be about 66. $88.5. It's going to be about right here. That will go all the way to 100. Right here. That is A3. I'm not going to fit 3 more on top of there, am I? It actually doesn't matter because we just ran out of time anyway. But I think I got the point across of how this works. In fact, if we did, even without drawing the pictures, we can look and see this is the one that's going to be problematic. This one barely got across the threshold at one point, but only just. And if this had been the only infraction, maybe you do something about it, maybe you don't. This one obviously is going to be an issue, but this is how you can put them together and put them all on one scale and compare them and see where you would have like your threshold of 120 right here going all the way up. C'est bon? You ready for a holiday? No, you already said you don't get one. What about homework? Have you got any homework questions? Okay. You have turned in the last week's homework already, right? Okay. I know